The Voyager space probes have been traversing the solar system for more than 4 decades and are now in uncharted deep space, farther than any spacecraft has gone from our planet. Through this journey, the probes have provided valuable data that have led to numerous breakthroughs over the years. But now it seems that Voyager has been sending signals that have our scientists baffled. Keep watching until the end of this video as we look into how the NASA Voyager made contact with an unknown force in space. The revelations are mind-blowing. Voyager. The Voyager space probe consists of Voyager 1 and Voyager 2, which were launched 16 days apart in 1977 by American Space Agency NASA. As of early December 2022, both these space probes have been operating for more than 45 years and 3 months, making them the longest probes in operation. Currently 14.5 billion miles, or 23 billion kilometers from Earth, Voyager 1 is currently the most distant human-made object from Earth traveling deep space. The pair is beyond the sphere of our Sun's influence and are still heading outward well beyond our solar system into interstellar space. These probes were built by NASA's Jet Propulsion Laboratory, or JPL, which is a division of Caltech in Pasadena, California. The Voyager program is a US-led scientific program that aims to collect and transmit useful data of observations back to Earth as it traverses deep space. These probes have gone past the outer boundary of the heliosphere in interstellar space, traveling with a velocity of 38,019 miles per hour, or 61,185 kilometers per hour. Voyager 2 officially reached the interstellar medium, which is the matter and radiation that exist in the space between the star systems in a galaxy, in 2019, while Voyager 1 reached the area first back in 2012. This is a region of outer space beyond the influence of solar wind, with plans of reaching the Oort cloud well beyond interstellar space. The probes have already made flybys of Jupiter, Saturn, and Saturn's largest moon, Titan, and have provided valuable information studying the weather, magnetic fields, and rings of the 2 gas giants, while also providing the detailed images of these planets' moons. Voyager's cameras have so provided data and photographs that aided in charting Jupiter's complex cloud forms, winds, and storm systems, while also being able to discover volcanic activity on Jupiter's moon, Io. Voyager also documented the enigmatic braids, kinks, and spokes on Saturn's rings. As it passed Uranus, Voyager 2 discovered a substantial magnetic field around the planet and 10 more moons previously unseen. It also uncovered Neptune's 3 rings and 6 unknown moons. Both the Voyager space probes also proved valuable to discovering the existence of a hydrogen wall at the outer edge of the solar system, which the probes first observed in 1992. Despite being so distant, both probes communicate with scientists of Earth using NASA's Deep Space Network to receive commands and to transmit data back on our planet. So far, Voyager has already done things no one has predicted and promises to outlive its investors to provide a deeper understanding of scenes well beyond our normal purview. Both these probes now have extended missions of locating and studying regions and boundaries of the outer heliosphere, while also beginning to explore the interstellar medium. While Voyager, now 45-year-old probes, are considered models of endurance, it continues to send data back from space using decades-old technology. However, early in 2022, NASA announced that Voyager 1 had been sending back mysterious data. Could it be that Voyager had just made contact with an unknown force in deep space? Voyager 1 glitch. Voyager 1, which was launched by NASA in 1977, passed into what scientists call interstellar space in 2012. And has since kept going. While the space probe is still operating properly, scientists focused on the Voyager missions recently noticed that it appeared to be confused about its location in space, without going into its preset safe modes or otherwise providing a notification of alarm. According to Suzanne Dodd, the project manager for Voyager 1 and 2 at NASA's Jet Propulsion Laboratory in California, a mystery like this is sort of par for the course at this stage of the Voyager mission. The spacecraft are both almost 45 years old, which is far beyond what the mission planners anticipated. We're also in interstellar space, a high radiation environment that no spacecraft have flown in before. It appears that the glitch has to do with Voyager 1's altitude articulation and control system, or AACS, which keeps the spacecraft and its antenna in the proper orientation. The AACS seems to be working optimally, since the probe is still able to receive commands, act on them, and send valuable scientific data back to Earth with the same signal strength as before. However, the AACS seems to be sending junk telemetry data. The data being sent to scientists doesn't seem to be reflecting what's happening aboard Voyager, with the input appearing to be randomly generated, without reflecting the actual possible state the AACS is currently in. The scientists do affirm that the probe is still able to receive and decipher instructions sent to it, despite its great distance from us, which takes about 2 days to send a message and get a response from the spacecraft. According to NASA, the team will continue to monitor the signal closely to determine any invalid data that may be coming directly from the AACS or another system involved in producing and sending telemetry data. This is valuable to assess since understanding the nature of the issue can allow the team to anticipate how it may affect Voyager in its mission of collecting and transmitting important scientific data. Once the team uncovers the source of the issue, engineers may be able to solve the concern with software updates or by using one of the spacecraft's redundant hardware systems. Voyager 1 has also encountered other obstacles, such as its primary thrusters showing signs of wear and tear back in 2017, where engineers had to switch to other thrusters on the craft, showing just how remarkable its design truly is. Another Voyager mystery. Aside from this seemingly innocent glitch, Voyager 1 also made waves when it was uncovered that it had measured something out of the ordinary. In 2012, Voyager 1 crossed the heliosphere boundary, the magnetic bubble inflated by our Sun. Since then, most of all measurements done by every spacecraft launched from Earth had been made within the heliosphere. And now, 8 years into its interstellar journey, a keen listen of Voyager 1's data are providing new insights into what the unknown frontier of deep space is like. According to a study published in Nature Astronomy by Cornell University PhD student and member of the Voyager team, Stella Acker, reports of what may be the first continuous measurement of the density of material in interstellar space may have been received from Voyager 1. Previous studies have only shown sporadic bursts of data, while this new finding shows Voyager 1 measuring long-lasting series of waves. Acker states, "This detection offers a new way to measure the density of interstellar space and open up a new pathway for us to explore the structure of the very nearby interstellar medium." It seems that NASA's Voyager 1 space probe was able to capture and send back sounds of interstellar space using its plasma wave instrument, which detected the vibrations of dense interstellar plasma or ionized gas, with readings made from the end of 2012 to early 2013. When thinking of interstellar space, one may think of a silent, serene environment, but that would be a huge mistake. Like the ocean, the interstellar medium is full of turbulent waves. The largest of these waves come from our galaxy's rotation, as space pushes against itself, leading to undulations reaching tens of light years across. Smaller waves are also measured, which often come from the rush of a supernova blast. Many of the smallest ripples often come from our own Sun, due to the solar eruptions that constantly occur, sending shock waves through space that fill up our heliosphere. These waves also reveal the density of the interstellar medium, since the waves vibrate the electrons around them as it reverberates through space. This allows scientists to take in the readings to pinpoint the frequencies depending on how crammed together they are. The higher the pitch of the ringing, the higher the electron density. In November 2012, merely 3 months after passing through the heliosphere, Voyager 1 was able to hear interstellar sounds for the first time, with another whistling sound that was louder and more higher-pitched detected 6 months later. As Voyager 1 traversed through the interstellar space, it seemed that the interstellar medium appeared to be getting thicker. While these momentary whistles now come at irregular intervals according to Voyager's present data transmissions, these findings provide an excellent way of studying the interstellar medium's density. Because of this, scientists were able to regularly sample the density over a very long stretch of space, providing us with the most complete map of the density and the interstellar medium itself, as observed by Voyager. So, what do you think about these space mysteries? Let us know in the comments below. Space Infinity will continue to deliver the latest news on the vast oceans of space and all its new discoveries. So tap that like button and subscribe. We'll see you in the next one.